And stick around because we've got a cocktail or a champagne reception sponsored by O-Power and First Fuel that we'll go directly into right after this panel session. But come on out, folks. Stephen Lacey, who is a senior editor at Greentech Media. If you read the site, you've most certainly read some of his writings. And in addition to that, he hosts a very interesting and engaging podcast called The Energy Gang. So I'm sure Stephen will have a lot of great questions for these panelists looking at some of the underlying technologies of the soft grid. So welcome, Stephen, and I'll let you introduce the panel. And feel free to, we're getting this started about 15 minutes late, so we can end around 5:15.
Okay, great. Thanks, Rick. Hey, everybody. Stephen Lacey with Greentech Media. And we've got the final panel of the day, so we are standing between you and your champagne. So hopefully it'll be an engaging conversation. And I think throughout the day, we've sort of been evaluating the body of the car and how as the car is in motion. And in this session, I want to pop the hood and take a look at the underlying engine of how these companies are operating, how they're building their algorithms, and of course, the decision-making behind it and the applications that we've been talking about all day. So we have a great lineup of folks who can speak to this, two startups, a mature networking company, and someone from ARPA-E who works very closely with very early stage companies and can see what's coming up on the horizon and some of the challenges that they're dealing with. So joining us is Tim Heidel. He is the program director of the Advanced Research Projects Agency for Energy, the agency that works, of course, on very early stage technologies and tries to solve the pre-commercial scale challenges that we see from very early stage inventors and startups and university labs. We have Dr. Noah Rushan-Ramini, who is the founder and CEO of Grid4C, a predictive analytics company based out of Israel that is coming into the US. Anil Gadre, the executive vice president and chief marketing officer of Silver Spring Networks, an Internet of Things company trying to get into the broader Internet of Things, smart cities, smart meter networking that everyone here has obviously heard about. And Andy Cronk, the CEO of Tempo IQ, another startup doing temporal analysis for smart grid applications and other applications such as healthcare and so forth. So let's start with you, Andy, and talk about your underlying database. You sort of change your name from TempoDB to Tempo IQ, and you're now focused on sensor management through temporal analysis. What does that mean? I promise that this will be the last time today that you'll hear cloud-based data analytics, but explain to us what exactly that means.
Great. So hopefully I can demystify that. Maybe the best way to go about it is to sort of say, how the heck did I get to sit up here on the stage? So I used to work in geothermal energy. And in geo, the big question is always, does this actually work? Should we pay a premium for this? What's going on, right? And when I was working in this company, they had no way to actually prove that, right? It's sort of, we want to get accountability through data, but how do we do it? And so I set out to solve some of those problems, right? First, I said, let's model all the devices out in the field. Let's capture it at a rate which we've never done before. It's not, let's just look at a meter or some output. Let's look at the inputs. Let's go behind the meter. And let's go, instead of once an hour, let's do every second, right? And those are the type of problems I started solving. And so it sort of broke down into 4 categories. One, we need a canonical way to model all the devices in the field. Devices, sensors, the hierarchies involved. 2, if we are really going to try to understand what's going on there, we need to be capturing things at a very high rate. Let's really invest in storage. And we can't just be, let's just put it all in disk, let's just throw it all in some data warehouse, because we're sampling at such high rates, and we want to keep it all forever. Where's the rub? So we thought a lot about storage. The third piece was, okay, now that we store it, what sort of built-in tools do we need to start analyzing? Things like roll-ups, aggregations, interpolations, missing data, timestamps that never aligned. Started working on stuff like that. And then to really drive it home, it's one thing to just model what's going on and store it all and start analyzing it, but what's happening right now? Could you take historical information, create a model, and then apply that in real time to push stuff out? Those are the type of problems that we started solving, and we kind of bund it all up and call it sensor analytics, but that's the kind of stuff that we do.
Yeah, so how does that differ from products that use historical data?
Yeah. And so I think at least where we're finding good traction in the market is you have the one side, the historical side, right? Very important. You need sort of a brain or a memory to know what's happened, but then pairing that with the real-time side or the push side, it's sort of a push and a pull. And I think why people are choosing us is because we have that integrated system, push and the pull together. So we're very much, we call it, I don't like to use the P word, but it is a platform. People build on top of us. Maybe what's unique or different, maybe that's from what's happened in the past with utilities is this is sort of like an IKEA bed, right? Some assembly required. You have to do something, and your developers need to actually use these tools. And so it's interesting when I made the jump from a geothermal provider into a larger analytics player, everyone told me utilities, they just want to buy solutions. They don't want to do anything. And to some extent, I found that to be true, but what's really fascinating to me is how much every company is becoming a software company, everyone's staffing up, and they're really creating their differentiation between what are they going to do with the data, what kind of unique app or unique insights can they derive. And so we're focused on sort of underlying platform infrastructure, and that's our take on it.
Okay.
Yeah.
And I want to talk about some of the challenges in creating something that's not necessarily plug and play for utilities, but moving on. Dr. Ramini, you stress the need for predictive analytics and not just historical data, just like Andy was talking about. What does that mean in terms of the way that you designed your algorithm, and talk about Grid4C as a company, which also recently rebranded like Tempo IQ did?
Right. So what we do in Grid4C is foreseeing. We provide predictive analytics. We leverage the most advanced machine learning capabilities. Personally, I have
And you have a
PhD
machine
in
learning
machine
background,
learning,
yeah.
yes. And we provide accurate granular forecasts. And I think that's what makes all the difference, because everybody's talking about data analytics today, and there's a really wide range, and I want to talk about it a little bit. Because data analytics, it can be slicing and dicing historical data. It's important to do that. It could be, visualizing the data, censoring the data in real time. But the real value, according to analysts, is in predictive analytics. So you could really detect a system failure in real time, but you could also get up in the morning and say, I want to see all the systems that have more than 80% probability of failure for this week. And that's where you could be proactive. And that's where you could really influence tomorrow's bottom line results. So answering questions like what will happen and how will I make it happen requires a much more sophisticated level of algorithms. These algorithms, it took time for these algorithms to support big data, to be able to, and it needs, in order to leverage that, really to work with big data, you have to have them fully automated. So they're scalable and you can leverage that. And that's what we're all about. So usually there's a trade-off between the accuracy level and the time to process. And that's a challenge that we're constantly tackling. We're able to predict millions of meters at the granular level. We can disaggregate them and aggregate them to the feeder, to the transformer level, provide forecasting at the sub-hourly level, 24 hours ahead, a week ahead. And we predict outages, system failures. We predict on the operational side, on the marketing side, we can predict customers' response to energy efficiency programs. We can predict their behavior. We can predict their response to demand response programs. We could predict churn for deregulated market. And all these we even detect early warnings of irregularities at the household level as a part of our customer engagement solution. So even as a part of a customer engagement solution, you can provide insights with a predictive nature, foresights for the end user, for the customer, or detecting about irregularities that are going to happen, or you're detecting that at a very early stage, has a lot more value for the utility, for the end user, for all the value chain of the electricity value chain, actually.
And so, okay, if I'm a utility executive, I'm evaluating the difference between these two startups. Like, what are your underlying assumptions that are different from, say, what a Tempo IQ would do? How would you differentiate and talk about the mathematics, the assumptions behind what you're doing?
Well, I would say that Tempo IQ, it seems like the perfect platform for us, because what's interesting about machine learning is, you say that there's garbage in, garbage out. The more accurate The more real-time data, the more granular data you get as input, the more accurate, granular, and reliable your forecasts are. So if you have, missing data, and so our algorithms are robust enough today. They have to be to deal with missing data because this is what's available today. So we developed them to be very robust. Still, the better data we get as input, the better output we provide, the better forecast we provide.
So Anil, let's turn to you and talk about the Silverlink sensor network that you recently rolled out. And you're talking about tying together meters, sensors, other management platforms, and gathering information, creating actionable insights at a tenth of the cost of a warehouse style analytics. Like, what are you doing differently, and how would you achieve those performance goals?
Well, if you take these two stories, right, the commonality, and now add 100 other software players and innovators, the common problems they have are: have a great idea, have the algorithm ready to go, where the heck is the data, right? So they are starving for real live data. And by the way, one of the problems on the utility side is, as badly as the utility might actually want to experiment with these kinds of ideas, internally their own processes and systems are such that they may not actually be able to get them the kind of data that they want in the kind of time that they want. So one of the things that happened over the course of really a couple of years of sort of watching what's happening here, we realized that one of the key things that we could do is expand our platform. So phase one was get everything up connected, right? Good news, it got connected. And by the way, it was sort of sending a ton of data that hadn't ever been gathered before. Now the problem is, how do you, in a radically lower cost way, get it to the people with the ideas? So that actually brings to us a related point, which is, everybody, I feel like when we talk about big data, the conversation often sort of implies that there's a giant big app that's going to be the winner. And I believe that what's really going to happen is it's actually going to be 100 little apps, because different constituencies inside the utility are going to want those, maybe not micro, but sort of mini apps, right? And not, so OMSs and DMSs aren't going to go away. But by the way, the three that you can reel off as being sort of the classic big apps for the back end of the business side, I think are going to be replaced by hundreds of little apps that add value, but in aggregate, they actually probably add vastly more value than anything's ever done before. Mostly because we have more data, the continuous connection. And I guess the last point I would make is, I'm starting to see the beginning of the fact that the real value might come from the crossover of these domains, meaning a data from one space influencing and actually affecting an outcome in a completely different one. So AMI data is being used basically to send people a bill, right? Okay, one big leap forward was we might want to give them a portal or send them direct mail and show them what usage was on the consumer side. Now that AMI data can actually be used by NOAA to radically change forecasting, which was impossible before because granularity wasn't available. And so I mean, that's just the tip of the iceberg with the possibilities.
Yeah, actually, I really like that idea. And the one question that maybe it's a bit of my own ignorance, but I really like the idea that you're going to expose this data and there's going to be, let 1 million apps be born. Who do you think is going to make it? Is it going to be a bunch of niche providers, ISVs? Is it going to be internally, the utilities are going to go make themselves? Or how do you say that?
I think the answer is both. Yeah. I believe there are very smart people inside utilities who today are basically living in the what they can get done with Excel and pivot charts, right? I mean, that's, you're laughing because you're doing that, right? And there are smart people out there who are domain experts who know more about how the grid actually operates than you can find anywhere else. I've also had the same sense that they're university professors with great ideas, fundamentally starving for the data. So ultimately, by the way, it's the utility who's going to be in charge of deciding who to provide that data to. It's not us, Silver Spring, doing that. It's the utility is going to decide which ISV, which software partner is interesting. And what I see our job to be is bring choice. Not to make this a sermonette, but our whole history has been about, get device choice. Well, here, It's like we already have 3 different load disaggregation partners because you know what? I have no clue how to pick which one's the better algorithm because they each tell a fabulous story, and I'd rather have the customer decide which one's the better, and probably there's a 4th one hiding in your head that you'd like to make it in the mix. Great, more the better.
And just following up on that before I go to you, Tim, sorry. Silver Spring has been a good networking company. Can it actually be an effective analytics company?
Oh, that's like a deep philosophical who am I question. Okay.
Maybe I should have saved that for last.
No, I think that's a good question because we ultimately are a platform company, right? And Wave 1 for the last decade was basically a networking platform that connected stuff. If you could read Silver Spring bars, which my phone can't do, right here you'd have Silver Spring bars in the air flowing through here, right? Because we cover PG&E over here. So, but I think this is a logical abstraction of what the meaning of the platform is. So first there was the physical connectivity, control plane, getting data back and forth. And I think this is a logical thing, which is to say the next step up is how do you actually make a abstraction such that you can enable ISVs. Now, to specifically your question of are we trying to be in the analytics business? I think we will make a few applications that make sense, and by the way, maybe 99% of our customers will want, and they're make sense to make. But my view is that the majority of applications will come from other people, which is why we sort of broadly invite anybody with a great idea to build on top of Silverman. Yeah.
Tim, over to you. So ARPA-E has made renewable energy integration and grid modernization a key priority, and of course the software layer has been really important, and you've funded, with each funding round, $2 to $3 million for a lot of companies developing these different analytic capabilities. What are some of the top companies that you're actually funding, and what are they trying to do?
Sure. Well, let me back up a little bit and tell you how we got into this space, because I'm definitely not a data analytics person. I was forced to get into this over the last couple of years because it was such an obvious answer. That one of our main missions that ARPA-E has handed to us by Congress in the US is emissions reduction in energy. Renewables is a big piece of that, right? And your first blush, and I think we heard some of this morning, is, well, of course, the answer is energy storage. I have colleagues who work on energy storage, and I really hope the costs come way down and we can build really massive energy storage at grid scale. But a couple years ago, we said, well, what happens if that doesn't come true? What happens if it takes longer than we hope? What else can we possibly do to help this? And we said, well, it looks like there's an enormous amount you can do on grid operations. Improving grid operations, giving people much better information about how the grid is operating, what state they're in, and forecasting out how to improve that operating profile over the next hour or next day. And that naturally leads you to some on the hardware side. So we've funded a number of projects on power flow control hardware, for example. It's lower cost alternative power electronic devices. Now, we were targeting most of those to mesh transmission networks. I think there's a lot of applications for those in distribution networks as well. And I saw Deepak here earlier. We've supported some power router development at Greentech, for example. But it's not only the hardware. You need the hardware, but then having a single hardware device is never going to be sufficient. You really want a fleet of these deployed throughout your system. Whether it's doing volt-var at distribution system, or whether it's doing power flow control in the transmission system, or perhaps even the distribution system, you need the optimization systems to wrap around that. And some of those optimization approaches can actually be substitutes to hardware. We funded two teams, two university teams. We fund everybody from universities to small startups to large companies. We funded a team at Texas A&M and a team at Boston University who are looking at line switching for transmission networks. This is the idea of when you're operating off-peak, if you have a local congestion issue, sometimes the simplest way to solve that is simply to remove one line from service. That takes an enormous amount of optimization power to find what lines and when, and how do you know it's actually safe to do that? And so we've had a couple projects in that area. Of course, active demand dispatch is another big area. And so we had a project that concluded earlier this year with AutoGrid for looking at customer demand response forecasting in a highly granular nature all the way down to individual nodes and individual customers eventually. So we're really excited about that. And of course, we've also had a number of projects looking at the utilization of cloud computing resources just because it allows you to do so much more. So we had a project who's been led by Cornell University over the last couple of years in their computer science department, trying to wrap high consistency data or guarantees around data consistency and reliability around public cloud infrastructure so that you can do some of these really important real-time high reliability applications.
So I want to go back to what you said in the beginning there, and that was that the software can do what the hardware might be designed to do. And I'm just curious if ARPA-E shifted from a invest first in hardware approach to thinking about software more.
No. In this space, we have always been doing both at the same time. So actually, one other project that I'll highlight, which is local, is we started a project early last year on what are being called micro PMUs, or they're phasor measurement units for distribution systems. So it's essentially a very accurate power quality monitor. It's an industrial power quality monitor that you're integrating with a GPS antenna. And it can give you the accuracy that you need to be able to pick up very small phase angle differences to diagnose how your distribution system is operating. Well, we went into that project, and about half that project is focused on the hardware. Building the hardware, testing the hardware, validating that it works. About half the project is then doing a lot of careful work on developing the diagnostic applications and the control applications to use that hardware. You know, one of the things that we've found over the last couple of years, and we have one of the programs that I manage is called our Genie program. It's our big power systems program at the moment. And about half that program is hardware development, about half that program is software development. And if you were to get all the hardware development guys into a room and you ask them, what's the hardest thing that needs to be completed and what's the big challenge here? What is the grand challenge that's ARPA hard? And they would say, building low-cost, reliable, resilient hardware for power flow control is the most important thing you could possibly do. And as soon as we build that hardware, all the algorithms and the software and the analytics will all just fall into place. Okay, if you go to the other half of the program, if you get all the software people into a room, and you ask them, what is the ARPA hard challenge here, and what should we be focusing on? Every last one of them will tell you it's all about the optimization, the data analytics, and how you dispatch those devices. And if only we could do that in a reliable fashion and fast, all the hardware would just show up tomorrow. And so we've had a lot of fun getting those two communities to talk to each other and learn their vocabularies. And it's been so critical, I think, to the early successes of some of those teams.
And you did say that some of the applications you're funding are perhaps more suitable or just as important for the distribution system when you thought maybe they were for the transmission system?
I'll tell you, I've been learning a lot today. Most of my time is spent entirely focused on transmission system operations and thinking about the transmission system. And I do think there's a lot of applications potentially in distribution systems that are becoming a lot more dynamic, right? Historically, at the transmission system, we've relied on a lot of operator intuition to operate the grid reliably, right? As the system becomes a lot more dynamic, that becomes a lot harder to do. We have to get much better at knowing exactly what state our system's in and how we can operate it best. In the distribution system, because you didn't actively manage it all that often, instead of operator intuition, you largely relied on engineering rules of thumb and just simply building an extremely robust system. That's becoming a lot harder to do these days. Right? We already have a lot of infrastructure in this country that's extremely old. We're already backing ourselves up against an investment wall that we're going to need to spend an enormous amount of money just replacing what we already have, let alone all of the new. And so you have to find ways to invest more intelligently. And I think some of the optimization schemes that we've been developing with an eye towards transmission certainly could be adapted. It won't be a drop-in replacement. But especially around a lot of the distribution system operator concepts, some of that math probably applies.
All right, so let's apply that to what utilities want and are asking for. Noah, you identified a lot of different areas that you're talking about: outage prediction, customer churn. overloaded circuits, all sorts of predictive capabilities. And I'm just curious if you went in with a particular set of tasks or priorities in mind for utilities and found that they wanted something different, which I often hear from many companies.
Well, actually, that's exactly what happened to us. So we started with operational solutions, started with granular forecasting. It was almost 2 years ago that we started granular forecasting and detecting irregularity at a very early stage and outage prediction and so on. And what happened to us is we would go to the utilities and show our solutions, and the people from the marketing side would just grab us. Could you do this? Could you do that? And could you predict churn? Could you predict the response to demand response programs? And so could you cluster, bottom-up clustering of profiles so we could really know how to build our marketing offering, our energy efficiency offering, our demand response offerings. We really want to understand how our customers are acting. And the number one usually request is for a customer engagement solution. And they want to see how, everybody wants the most sophisticated insights to provide to their customers. And we provide very sophisticated insights. And I think the reason is it's really easy, an easy place to realize value because there's in many cases there's a vacuum there. So it's building from scratch. And that's why we start there. In the operational side, things are moving slower, but are moving. But definitely the customer analytics and the marketing side, that's where most of our projects are today. Although we started with the operational side, that's my background. And so...
and are they building off of that? I mean, and by the way, give us a context for type of customers you have in the US and in Israel and elsewhere. I mean, what is your customer base like? How big are they? And are they mostly pilot projects or are they actually implementations?
So, we started in Israel, so we're working with all Israelis, IPPs, and with Israeli electricity company and piloting in the Israeli smart city. And our focus was Europe. So we're working in Europe, and we didn't plan to enter the US market. But what happened to us in the US is that there was one very big electricity retailer here that we started with a few use cases in solving them. What we usually do when we come to a utility or an electricity provider or electricity retailer or distributors, what we usually, and this has to do with I think it was Frankie today that talked about dating at the first stage, and Jason talked about not needing to integrate systems if there's not a real business justification. And so what we do is we say, okay, let us show you how much value we could provide. Give us a sample of the data. We explain how to sample the data correctly. Sometimes we sample the data ourselves so the data won't be biased. And then we will come back in 2 or 3 weeks and show you what we could do. Tell us what your biggest business problems are. We'll show you the value that we could produce with that data. And that's how everything starts. We started that in the US market, and what we were told by this prospect or utility is they said we had many vendors working for us for months that weren't able to provide the amount of value that you're able to provide in 2 weeks. So that's what predictive analytics, that's basically what predictive analytics can do. And what happened is we were getting more and more projects and solving more and more business problems.
So how many?
So in the United States, we're just piloting today. It's proof of concept, it's piloting, but a lot of them. And so that's why we decided to enter the American market sooner than we thought.
Let's talk about applications again. And Andy, when we talk about the soft grid, we're thinking about, you're working with specific solar developers and not just utilities, and that they're a customer of yours. So we're not necessarily talking about people who are operating the grid, we're talking about folks that are installing solar projects and monitoring those solar projects. How are you creating the underlying analytical capabilities for the microinverters and the folks with the software layer, and what are you actually doing to monitor those solar systems for developers?
Yeah, it's really interesting. I said, again, the background was in geo, and we were a design and build firm. and went out and solved a bunch of problems there. Come out and see all the different layers of solar that we get to work with. We get to work with microinverter manufacturers who want to differentiate by saying, okay, yes, maybe our widget is 10% more efficient, but we also have this really cool analytic system to prove it to you, right? So we get to work with those kind of companies who are classically hardware companies. We also get to work with energy management vendors. We get to work with software companies that are just powering their offering. And so we also work with installers who think that they can differentiate by, again, the whole idea is like visibility or accountability. So to me, it's been really interesting to see that everyone just in solar specifically, everyone in the stack from microinverter companies to large string inverter type companies, they all think that, yes, the hardware is one thing, but we can appear very different if we had the sort of platform behind it. Now, again, I want to be clear about where we fit in the stack, right? I think all these companies think they can differentiate with the experience that the end user gets, right? It's not that we all get the same plug and play dashboard, right? They think they can make their own app and create some unique insight, create something that's unique experience. And so that's kind of where we are sort of a laconic infrastructure provider. We give them all the tools they need to make that app as fast as possible.
And then just going back to my earlier follow-up, which was, is that a problem? Is there a problem selling into the utility sector when you have something that they need internal capabilities to actually build upon? And it's not just something that they can plug in and actually use right away.
Yeah, and I think why we haven't gone and ran really hard at utilities and instead have focused more on distributed gen is because at least the way I view it, and again, the context is I'm sort of new to working with utilities, but it seems like in distributed generation, it is a true market, right? These people are fighting to prove that they're better, whereas it seems like every time I talk to utility, you have to kind of pull them, and maybe it's the difference between the market and monopoly, but it seems like the incentives are interesting there. And so now that we're starting to work with more utilities, it's sort of because they have to. And so they're saying, okay, we need a place to store all this data. We need a place to build on top of, and that's kind of how we're getting into it.
So I want to take some questions from the audience because I know people have been here for a long time, but we're going to go a little bit over since we started late here. But Anil, I guess since we're talking about pivots and changes to business model, and I guess I'll ask another existential question. And that is like, what is Silver Spring today? I mean, you're doing demand response, you're trying to create these analytics layer, you're doing smart street lighting, you're networking smart meters. I mean, how would you define the company? You've got all these different nodes, and I guess one could be confused wondering what kind of company you are exactly.
Well, I definitely don't want to have anybody leave confused about who we are. So what I tell people is we are the industry leader in mission-critical infrastructure networking. Now, that's a mouthful. What does that mean, right? There's a lot of people who make networks in the world. We focus in on making networking for this very unique space of critical infrastructure. And in some ways, the utility company was actually the first one to start doing Internet of Things, even though they didn't call it that, right? And little by little, I mean, that's where we're headed. So
do you call yourself an Internet of Things company as well?
Well, if I brought my few thousand marketing slides with me, they would have on it things like, I believe we've been making the Internet of Things a reality in this space of critical infrastructure and increasingly in smart cities longer than anybody else. But I think that existentialist question you were asking about was, you reeled off a bunch of apps, right? You say you do DA and DR and consumer engagement. What are you? Well, the beauty of that is because it's a platform, right? And I think this is a very important point that you have accidentally gotten me to, or purposely gotten me to, which is that,
I'll pretend it's purposeful.
The history of this industry and many other industries, by the way, were vertical stacks of applications. And one of the most fundamental things that has changed as the internet came to every industry is it has become a platform on which you do multiple things. So these days, I mean, the only way I believe that utilities will truly get value out of the networks of the future and the ones they've built out is because the network can do more than one thing. In fact, if your network can do only one thing, you fundamentally chose the wrong one, because you're going to need to operate AMI and grid management and consumer response and call demand events all on the same network. Because if you heard Elizabeth's story about the grid of things, the speech just before our panel, that's what it was about. She was talking about a holistic environment in which all these things are going to have to work together. And work together implies that you can't really have separate networks. They better be one platform. So that's sort of when we say we do all these things, either directly or through mostly with our partners, by the way, that's how that wealth of applications actually shows up.
Tim,
So are you
over to
still confused about
No,
Vermeer?
not at all. No, it was
Good.
not at all. Tim, for companies that are developing software versus hardware or materials, what may they be? How much faster can ARPA-E help them get to market? And how do they differ from some of the other companies in ARPA-E's portfolio? Because you're talking about a company that needs far less capital and far less time to actually get into the market. So are any of the things that you're funding, do you see, obviously some of them are companies that are operating today, but how quickly do you think some of these applications that you're looking at will be at scale and be ready for utilities or whomever to integrate?
There's a real range. It's certainly easier and faster to deploy software. There's no question, right? The best part about it, in many respects, is you can run in parallel. There's no problem with running in parallel, right? A new software vendor can show up and play with a synthetic data set at first to show what value they might have, and the next step is, okay, put their system in use, but don't necessarily rely on it for critical functions at the very beginning, but prove that it works. You can rarely do that with hardware. Hardware, you're typically putting into a place where you're trying to use it at its full value right from day one, so you have to be a lot more careful at the initial deployment. And so we've actually seen a lot of instances at ARPA-E where software projects accelerate, and I've had some projects that in the third year of their ARPA-E project, they actually come back to us and say, we're coming up on that last milestone. That last milestone we think is really important for our business 2 or 3 years from now, but we've gotten so much excitement from some of our first utility customers. Can we delay that 6 months to allow us to focus on some of the shorter term needs with our utilities that we didn't anticipate a couple years ago? That we've been really excited to see that. We've been trying to work with those companies as much as we can. We're typically funding version 2 or version 3 of what they're trying to develop. We're not often funding something that is the very first need. But there's no question that they've been able to gain traction a lot faster.
Yep.
Small vendors are really starting to gain a lot more traction now.
Any questions out there?
You mentioned that we should have one network doing really important things, and I've heard it said, and maybe you can calibrate this for me, that if we took all the money that we'd spent on smart meters in California, we could have put free internet to every home in California and gone over the top. There's a lot of things that could have been done on the internet. Is it critical to have lots of different networks out there, or and could you speak to the idea of the cost that went into smart meters being perhaps used to provide free internet for everyone?
Anila, do you want to take that?
Sure. I guess I started by saying, our focus is the critical infrastructure. So internet as a protocol technology, you can build many different kinds of networks, that, I'm sure. So our focus has been how do you fuel critical infrastructure? I'm not sure it's that one thing can do everything. I mean, by the way, the same thing is true for the cellular story that says, hey, just because the cellular canopy is everywhere, it can deal with anything. It probably is not good for a lot of things, right? So yeah, we're going to have different kinds of networks. They're likely over time to all use the internet protocol, right? And then I think you're going to get down to, well, what apps run on them and so on and so forth. So, so I guess, and I guess the best answer to the value issue is what the speaker before us was talking about in terms of a specific point related to the earthquake, and did the network help them get that? I think she certainly said that, and we have evidence from Hurricane Sandy where, places that had smart grid were able to recover and restore power faster. So sort of grid resiliency are really big value payoffs, right? And beyond that, there's, I think, more possible when we start talking about truly, lots of distributed generation incorporated into managing the grid a radically different way than it's managed today.
We'll take one or two more questions and then wrap up right here. Yeah.
I guess, Anil, it seems to me, and maybe I'm wrong, but it seems to me that the lack of standards generally in this whole space is also inhibiting the progress a bit, or it's taking longer than it should. I don't know, would you agree with that? And from your perspective, do you perceive that as a problem, that there's a lot of different utilities are using different types of networks, and then there seems to be, versus in other industries where pretty quickly standards have been established and then innovation was able to explode, such as, let's say, consumer computing or things like that?
And others of you should feel free to dive into, because it's a pretty broad question, right? I think the utilities don't get enough credit for being innovative. First of all, they've got a tough problem, right? We as consumers expect magic to happen, and they actually make that happen daily, right? So the making sure that things work, and Tim just said, hey, software no problem, hardware, you drop it in and things don't work, bigger problem. So I would tell you that over the course of the 10 years of Silver Spring's lifetime, we have seen an increasing degree of standardization. And by the way, standards don't just happen in a flash all up and down the stack, right? So one of the most basic choices the company made at its founding was Internet Protocol, literally IP protocol. Over the course of time now, there's a globally ratified standard for 15.4G, which kind of gets us closer and closer to plug and play at the device level. And I think more standardization is going to come. That's great for device connectivity. I think the next wave is going to be all about, so how does data get used more easily? How do APIs show up? That's probably going to take a while, because that's so application specific, and it's hard to imagine standards instantly. So there, I think it's going to be driven by innovation, footprint, market share, those sorts of things. I don't know if you guys have feelings about that.
I like we sort of led to the idea of APIs, right? I think, at least the way that the rest of the internet's played out, there has not been a standard. The Twitter API is different than the Facebook API, but they're all published, right? You know what they are. You can do the glue, right? And at least that's a vision that I think makes sense. Now, I don't know if you're thinking about control and wireless protocols and all that kind of stuff, but the interface is what's important. And I think, to me, at least the first step is at least making them public, or at least allowing people to make SDKs around them. That's at least, maybe it's too abstract, but that's how I see it.
All right, so we're going to wrap up here, and I sometimes enjoy the cheesy bookend questions that get people thinking, and they can elicit some good responses, so bear with me. But I want to go down the line and hear from each company, sort of, if you could be doing something new or better from what you're doing today in terms of analytical capabilities or service offerings, what would it be? What would you be doing differently? And what do you want to add on to what you're doing currently? And Andy, I'll start with you. That's kind of a...
No, it's a good question. I think that when I look at the things what our customers struggle with the most, it is sort of, I mentioned one of the things we focused on is helping them model their data, what's out there in the field. It's a struggle for them. They don't know if the hierarchy is a substation and then it goes to a meter and then a house, or are these things siblings? I think that idea of sort of, if we could help them more readily model what's out there in the physical world, and then, of course, then send all the data online, the modeling piece is actually something that a lot of people I see struggle with, and I'd love to solve that for our customers.
And Neil, how about you?
I'd say two quick things. One is, how do we enable a greater variety of interesting new devices with radical new capabilities getting connected so they can spit out more interesting data? And the second one would be the complementary other part of it, which is, how do you really, in a big way, change how easy it is to create new applications inside the utility?
Noah?
I would say more applications for, there's so many use cases. And we're talking to, it's just developing more and more applications and solutions that predictive analytics can solve. It's getting, and reaching more utility, reaching more retailers. Just being able, to working with all of them, we really feel there's so much value there that we could provide to make things better for everyone. So reaching them, and of course, what we do all the time, we're putting a lot of efforts in research and development just to constantly improve the accuracy of the algorithms, the fact that they're fully automated, and the level of granularity they can reach and their performance time. We keep on improving that so we could really face a huge amount of granularity. We have today, I would say, billions of meter reads from 3 different continents that we're analyzing all the time and just deriving more and more value out of it.
Tim, I'll flip the question a little bit. You started, I think, by talking about lessons that ARPA-E had learned. And so how does that change the way you think about investing in companies that are working on these integration challenges going forward? Any more elaboration on that? I mean, given what you've learned over the last few years, anything you do differently in terms of when you talk to companies at conferences like this and how you evaluate them, how you think about the way the agency approaches this?
Fundamentally, it still comes down to our number one question, which is whenever we're evaluating a new technology, if it works, will it matter? Right? We can figure out all the rest later. We can work with teams to talk to utilities and figure out what the real problem is and what the first market is and how do they find funding. That's all things we can work with teams on. We're still looking at if it works, right? Will it matter? That's been a bedrock since we started, and I think will continue as long as we're here. I will say the thing that we're always extremely worried about is the handoff. We fund projects for 3 years on a fixed term to try and de-risk them technically to get them to the point where the private sector or other parts of government will pick it up and run with it after that. And we really want to be doing early stage stuff. I want to be funding stuff which 80% of you in this room will tell me that it will never work. And I'll prove you wrong over 3 years, hopefully, right? Or at least 1 in 10 will prove you wrong and it'll work. Today, we don't have a great mechanism for picking up and running with those early stage opportunities after ARPA-E funding. That's the thing that we really struggle with.
All right, good insight there. Let's thank our panelists. Thank you all for a great day. And over to you, Rick, for closing thoughts.
Thanks so much. So wait just 1 minute before you go. Throughout the day,